Así que comenzamos en unos minutos. Siéntense incómodos, vayan al baño, los que tengan que ir al baño, beban agua, estiren sus piernas y en unos minutos comenzamos. Gracias a todos por unirse. Bienvenidos a todos, le habla Samuel Vélez de aquí de la compañía Chimaxo Scientific Instrument, coordinador de ventas y servicios. Primero que nada, le quiero dar las gracias a todos por estar aquí, por la participación en este seminario webinar. Vamos a estar hablando en inglés. De aquí en adelante voy a cambiar a inglés. Vamos a estar hablando en inglés. Pero si usted tiene alguna pregunta para nuestra gente de habla hispana, si tiene alguna pregunta la puede hacer en el chat en confianza en español. Y también puede abrir su micrófono y hacerla en español. Y con mucho gusto vamos a aclarar cualquier duda que haya. Good morning, everybody. For those that speak English, we are here live today. This presentation is going to be conducted in English. For benefit of other people and education purpose, this presentation will be recorded. So please be aware that we are recording this presentation for education. I want to welcome everybody to our webinar. Today we're going to be talking about recycled plastic analysis with FTIR. I'm pleased to present our main people that are going to be presenting on this webinar. With me, we have today Dr. Ruth Marfil Vega. She's our marketing manager. And we also have our product specialist, senior product specialist, Mr. Lian Shao, PhD. He's going to be driving most of the presentation today. Before we start, I just want to make a brief introduction. First, Dr. Marfil Vega will be talking to you guys, presenting, opening the seminar. Just so you know who our marketing manager is, Dr. Ruth Marfil Vega is our senior marketing manager for environmental at Shimazu Scientific Instrument. She has 18 years of experience in environmental chemistry and engineering in US and Europe, developing and implementing solutions for emerging water quality topic for various stakeholders, such as in the water sector. Before joining SSI, she established the R&D team focusing on the analysis of emerging contaminants at American Water, the largest water company in the US with 300 plus water treatment here in US. She worked also for EPA ORD in Cincinnati, Ohio for almost 10 years on project focused on the analysis of emerging contaminants and the implementation of in vitro bioassays for toxicity assessments. She received a PhD in environmental science from the University of Cincinnati and also a BS in chemistry from the University of Valladolid in Spain, in España. So please join me to welcome Dr. Ruth Marfil Vega on this presentation. Thank you very much for your attention. Please, doctor.
Thank you, Sam. Gracias, Sam. Good morning, everybody, and welcome to the webinar. Lian, could you go back 1 second? Thank you. Yeah, Lian, who will be speaking later, is controlling the slides. And I'm going to give a brief introduction about the topic of plastics analysis, and then Lian will continue the presentation, focus on the analysis of recycled plastics by infrared. Lian, can you move on next? As you probably been aware, we've been talking about plastics for a long time, and plastics pollution, because it's plastics don't disappear easily. They stay in the environment for a long time, and it's a big problem. It's becoming a very important problem. Traditionally, when we talk about plastic pollution, we think of the pictures that I'm showing on the right of the screen. You know, the beaches, the different places full of pieces of plastic, as well as the fishes and the birds that feed from the fishes and other places. But unfortunately, the situation has been changing dramatically since the pandemic, the COVID pandemic started last year. And it's been changing because of two things. One, we all, because we needed to protect ourselves, have started using again more single-use plastics, like, you know, the masks. Those were essential for us. And also we've been changing the recycling or reusing practices that we have developed in the past years to help control the plastic pollution. Like, for example, when the pandemic started and I needed to get groceries, I didn't want to reuse my recycled bags to go to the supermarket. So again, I went back to the practices that were more common years ago. Liang, would you mind going back for a second? So yeah, we all went back to practices that were more common 10, 15 years ago of not reuse so many materials, because as I mentioned, it was the priority that we lived since early 2019 was to protect our health. Next, please. So sometimes when we talk especially about pollution, we forget the overall the full life cycle of the plastics. And as I mentioned earlier, we use plastic for a lot of things, and it became very clear that it was even more essential since last year. So I'm just showing in the screen just a reminder for all of us to keep in mind that we need to protect the environment, we need to protect resources. Oil is gonna get exhausted in several hundred years. But we need to keep in mind that all the pieces need to work together. All the different groups, all the different laboratories need to work together to ensure that we have the products, the plastic products that we need in our daily life, while we keep the environment safe, as well as what's, I think, more important, our health, the public health. Next, please. In this slide, this figure that is showing in the screen now, it's very similar to the one on the left, but it highlights within the red square the key, the crucial role that the recycling industry plays in the full life cycle of plastics. It has a crucial role for conserving resources, generating new plastics, as well as protecting the environment. And the recycling plastics is the focus, the main focus of the next slides that Liang will be presenting shortly. So how Shimatsu can help you when you want to analyze recycling plastics that are going through the recycling process? And not only that, how can Shimatsu help you to provide analysis and assessment of the full life cycle of plastics? Well, Shimatsu offers a full portfolio of instrumentation, and I'm showing a diagram in the screen. You can get more information about this diagram and the analysis of plastic in our website. I'll put it in the chat in a second, where you can find the information. But as you can see in the slide, we have a full portfolio for characterizing plastics, either from the macro plastics, the big pieces of plastic, down to the micro sizes, the last pieces that we find in the beaches, at the parks, when the plastic goes to the landfills and they start breaking down. We have the solutions for monitoring each step. Also, the instrumentations that we offer not only are tools for analyzing the main polymers, the main components of the plastics. We also have solutions for characterizing the additives, the trace components of the plastics. If your part of your work is related to meeting compliance for ROS or other regulations, we also have solutions for analyzing those other tiny components that are present in the plastic, as well also anything that can sort on the materials. We have, as I said, the full portfolio of instrumentation for each of those applications. Liang, next. And as I mentioned earlier today, Dr. Liang Zhao will focus his presentation on FTIR, the use of infrared spectroscopy for characterizing recycled plastics. There's a couple of notes about Liang. He got his PhD at the University of California, Riverside, and he joined Shimadzu in 2017. He's one of the senior product specialists in the molecular spectroscopy group, and he's been part of his work has focused on the analysis of plastics for different applications for the past 2 years. So if you have questions about plastics analysis, he is one of the best resources that you can find within our team currently. And without further ado, I'm going to pass the mic to Liang, and he'll tell you everything about how to analyze recycled plastics by infrared. Thank you, everybody.
Okay, thank you, Ruth, for the excellent opening remarks. Good morning, everyone. Today, I'm going to talk about the recycled plastics analysis with FTIR instruments. Here's an overview of what we are about to discuss. First, I'm going to talk about a simple overview for plastics classification and the problem of plastic recycling. Second, I'm going to talk about the role that FTIR instruments can play for plastics analysis. And finally, and most importantly, I'm going to talk about Shimadzu offers, and it is called the Plastic Analyzer. With Plastic Analyzer, sampling measurement and data analysis can be greatly simplified. And okay, let's start the discussion. As we all know, plastics has now become an indispensable part of our life and work. And we can almost live without using certain forms of plastics. In general, plastics can be classified according to different criteria. For example, if we consider the chemical structure of the polymer backbone or side chain, we can classify plastics as acrylics, polyesters, silicones, polyurethane, or, and halogenated plastics. If we consider the chemical process that's used to manufacture the plastics, then we can classify the plastics as thermoplastics, which means the chemical process used is reversible. And examples of thermoplastics are polyethylene, polypropylene, polystyrene, and PVC. And if the chemical process is irreversible, we call these types of plastics as thermosets. And the typical example of thermosets is rubber. And of course, we can classify plastics according to various other physical properties. For example, we can classify the plastics as amorphous or crystalline plastics. And examples of amorphous plastics are thermosets, polystyrene, and PMMA. And the example for crystalline is high density polyethylene and PBT. So in this slide, we see the global production and fate of plastics. The blue curve represents the annual global production of plastics. And as you can see, over the past few decades, the tonnage of plastics production has been increasing steadily. And the other three curves represent how the plastics are being disposed of. And we can see the orange, which occupy a great portion, represent that the plastics are mainly discarded. And the red curve. The red curve represents the portion of the plastics that's incinerated. And the green curve is the portion of the plastics that's recycled. And we can see that the recycled plastics only occupy a small portion of the total plastics that's being disposed of. And ideally, we want to increase the amount or increase the ratio of the plastic that's being recycled. because the benefits of plastic recycling is very obvious. And those benefits are, first, plastic recycling can conserve resources and energy that's used for plastic manufacturing. And secondly, plastic recycling protects the environment from plastics pollution and greenhouse gas emission. And thirdly, plastic recycling can reduce our dependence on landfills. However, there are many hurdles that prevent the widespread of plastic recycling. One of the main challenges is sorting the plastics. And currently, there are several methods that's used for sorting recycled plastics. The first one is manual sorting, and this method obviously requires a large workforce, which is not readily available in many developed countries. And secondly, we can take advantage of density and the electrostatic property of the plastics to sort the plastics. However, there are limitations that will affect the accuracy of sorting by these methods. And finally, we have the sensor-based sorting. In this type of plastic sorting, different types of sensors are introduced into the sorting facility for better sorting results. And the sensors that can be introduced has many forms. And one of the category of sensors that's used will use spectroscopy techniques. And this is where FTIR spectroscopy can play a part in sorting recycled plastics. And why is FTIR useful for plastic analysis? So FTIR stands for Fourier Transform Infrared Spectroscopy. It is a reliable and cost-effective technique for identification of all phases of plastic samples. Here are some IR spectrum for some of the most typical plastics. And you can see the y-axis of the spectrum represent the absorbance intensity of the plastics, and the x-axis is the wave number or frequency of infrared radiation. The absorption of IR beams by different functional groups within plastics will give distinctive signature in the IR spectrum for easy identification of the plastics. So these examples on this slide is polyethylene, polypropylene, and PET. And by looking at the IR spectrum, we can see that each individual IR spectrum has very distinctive peak patterns. And by knowing the positions and the patterns of the peaks, we can easily tell them apart. Take polyethylene and polypropylene as an example for further discussion. Is it? Hold on. All right. So here in this slide, we have the infrared spectrum of polypropylene, or PP, and polyethylene, PE. And the green curve is the spectrum for polypropylene, and the orange curve is for polyethylene. And by looking at it casually, there are many similarities of these two spectrums. However, to tell these two species apart, we can look at the chemical structure of the PP and PE. And in PP, we found there is a dangling methyl group at the backbones of the polymer. molecule. And if we can find a peak that is unique to this methyl group, then it is a very good signature to tell PP apart from PE. In fact, we are able to find a peak at around 1382 reciprocal centimeters. And if we look at this peak in the green curve, it is obviously visible in the PP, but it's missing in the orange curve, which means the peak for methyl group can serve as a signature to tell these two species apart. And similarly, in PE, we have a unique peak at 720 reciprocal centimeter, which can be attributed to the linear methylene group, CH2 in polyethylene. And this peak is only visible in PE, but missing in PP. So by this example, we can see that the power of FTIR really depends on the absorption peaks and the peak positions of different function groups within different plastics. And because of that, we can use FTIR to easily differentiate different plastic species. And again, in this example, if we have a mixture of PP and PE, then we expect to see both peaks that can be attributed to the dangling methyl group and the linear methylene group. And in the black curve, which is a infrared spectrum for a mixture of PE and the PP, we are able to see these two peaks simultaneously. At Shimadzu, we have a sampling procedure with our FTIR instruments. Basically, we follow the flowcharts on the left of the slide. First, we will confirm and observe the samples. We will check for attached substance. And clean them if necessary. And next, we are going to decide which FTIR instrument to be used for plastics analysis. If the dimension of the plastics is more than 100 microns, we will choose a benchtop FTIR instrument, and usually we're going to use an ATR accessory for plastics analysis. If the dimension of the plastics is smaller, if they are between 10 and 100 microns, and these are considered microplastics, and they can be analyzed using FTIR microscope. So once we decide which instrument to use, we will collect data for the plastic samples. And finally, we're going to identify the samples by searching the spectrum against a database or a library. And before we go any further, I want to remind everyone the ATR technology. ATR is a widely used technology in FTIR. It is abbreviation for attenuated total reflection. And in this slide, the blue portion represents the sample, and the orange portion represents an ATR crystal. At the interface of the surface and the crystal, total reflection will take place. The IR beam enters the crystal and hits the interface of the sample and the crystal. And an evanescent wave is going to be generated at the interface. This evanescent wave only penetrates a few microns into the sample. And a very thin depth of the sample is probed, and the signal is reflected back and collected by the FTIR instrument. The advantages of ATR is very obvious. It greatly simplifies the sample preparation. Almost no sample preparation is required. All you need to do is to press the sample against the ATR crystal. And after the measurement, the cleanup is fast and easy. And this ATR technology is good for thick or highly absorbing samples because as I mentioned, the evanescent wave only penetrate a few microns into the sample. And finally, FTIR technology is good for both solid and liquid phase analysis. So here are some examples of FTIR plastic analysis. In this slide, we are going to analyze two types of straws used for beverage. They are made from two different materials. One is PHBH and the other is polypropylene. As you can see from the picture, they appear very similarly, and it's hard to tell them apart by just visual inspection. And we know the chemical structure of polypropylene, and we don't know the structure of PHBH yet. But here in this slide is the chemical structure of PHBH. It is a biomass-derived biodegradable plastics. And by looking at the chemical structure, we know that it's very different from that of PP. And we can use the FTIR to take FTIR spectrum of these two types of straws. And the IR spectrum are shown in the right portion of this slide. And we can see that they have very different infrared peaks, and they can be easily told apart by just taking the FTIR spectrum of these two materials. So this is an example of telling apart with the FTIR technology when we have materials that are very different. But how about measuring the same kind of material? Because in plastics analysis, we often meet with recycled or degraded plastics. It is desirable to tell the fresh sample apart from degraded plastic samples. In this example, we are studying the two different phases, the two different surfaces of a kind of PP window shade. So one side of the window shade is facing the window, which means it has more UV exposure. And the other is the internal surface, which has less exposure to the UV radiation. And if we take the spectrum of the two surfaces, we have the black curve as the surface that's window facing, or the outside surface. And we have the spectrum, the red curve represents the spectrum of the internal surface. And we also have the standard PP spectrum, which is the green curve here. And we can see that the internal surface spectrum is very similar to the standard spectrum. However, the window-facing surface has an extra peak around 1750 reciprocal centimeters. And that peak is attributed to excessive UV radiation. So ideally, if we have a library that contains all the spectrum for degraded plastics, we should be able to tell how much degraded the plastic sample is. And in fact, Shimadzu has such a library. And on the lower right portion, is our search results with the window-facing surface. And we can see that the window shade spectrum is matched to a PP sample that's irradiated with UV for 125 hours. So as you can see, FTIR can also be used to tell the degree of degradation of plastic samples if we have the appropriate libraries. So at Shimadzu, we recently comes up with a plastic analyzer. It is a plastic analysis system which consists of the hardware and the method package. The hardware is a IR Spirit FTIR spectrometer. And it also includes a single bounce ATR accessory, the QATRS. For the for the plastic analyzer method package, that include a UV damaged plastics library and a thermal damaged plastic library. It also includes a macro program and the parameter files for data analysis and report generating. And also a handbook in PDF format is also provided. So let's look at the hardware part first. The IR Spirit FTIR spectrophotometer is a compact-sized mid-IR spectrophotometer. Here are some of the highlights of specification of this model. You have the option to choose from 2 types of detectors, the DLA TGS detector or the lithium thallium oxide detector. It has a maximal resolution of 0.9 reciprocal centimeters, and it is very small. It only weighs 8.5 kilograms. And a dedicated program called IR Pilot comes with every IR Spirit spectrometer. And this is the user interface of the IR Pilot program. You can use the tabs or icons in the program to launch macro files that greatly automate the data analysis, data acquisition, and data analysis. This is what the ATR accessory looks like. The QATRS ATR accessory fits nicely into the sample compartment of IR Spirit. And this is what the instrument look like with the QATR sitting in the sample compartment. As you can see, this is almost an integral part of the IR Spirit spectrometer. For the plastic analyzer method package, we have 2 degraded plastics library, and Shimadzu is a company that provides libraries for degraded plastic samples. In the UV damaged plastics library, we have more than 200 spectrum of 14 types of plastics that's either not irradiated by UV or irradiated by UV, using a system that's developed by a Japanese company. And the samples are irradiated between 1 and 550 hours of UV radiation. In the system that's developed by the Japanese company, UV irradiation of 550 hours is equivalent to UV exposure of about 10 years. In the thermal damaged plastic library, we have more than 100 spectrum for 13 types of plastics that's heated between 200 and 400 degrees C in an electric furnace. The macro program can be launched from IR Pilot. It is a dedicated program for IR Spirit, and this macro program will greatly simplify the procedure for sample measurement, data analysis, and report generating. Next, I'm going to share with you some short videos that will show you the whole process of running a sample with the plastics and with the plastic analyzer. So this blue screen is the launch screen of Lab Solutions IR, our software for controlling the FTIR spectrometers. We can launch the IR Pilot by clicking the IR Pilot tab from the menu of macros. Once the tab is is clicked, the Lab Solutions IR will try to launch IR pilot, and it will start by initializing the FTIR instrument, which is the IR Spirit. So instrument initialization will start. It will go through the initialization checks. And once the checks are finished, the IR pilot will be launched. So this is the graphic user interface of IR pilot. And you can see at the lower left corner, we have the plastic analysis macro that can be used for plastic analysis. Next, we will click the plastic analysis tab to begin plastics analysis. So as measuring, just as sample measurement for other types of samples, it will first ask for a background scan. And then the background scan will be started. After that, we'll start the sample measurement. We can set the sample on the ATR. And the macro program will start sample measurement. And then after that, it's going to search the obtained spectrum against the libraries. And we will have a result, the search results, and it's asking you whether you want to save the result or not. And we can type in a file name for report saving, and the report will be saved, and measurement is finished. And then we can open the report after the measurement is done. And this is what the report will look like. So in this report, we will have the spectrum for the sample, and we will have the spectrum for the top 3 hits on the search results. And we will also have detailed information of the top 10 hits that's searched from the library. And each results will have more detailed information in the comment part. And then we can look at what's available in the data report. So in this example, the top hit for the sample is a polyurethane sample that's been UV irradiated for 200 hours. The red curve is our sample measurement, and the black curve is the search results polyurethane spectrum. And in this report, we will have more detailed information about the polyurethane sample. And we can see that the polyurethane is from the UV damaged plastics library, and the name of the sample is polyurethane. And the system or the method that's used for UV irradiation is this super acceleration weathering chamber developed by Iwasaki Electric Corporation, the Japanese company that I mentioned earlier. And the irradiation source is the metal halide lamp, and the irradiation time is 200 hours. And the method for data acquisition is single reflection diamond ATR. And as you can see from this video and the earlier introduction, any analyst can use the plastic analyzer with ease to measure and analyze samples and generate a data report. And many common recycled plastics are included in the UV damaged and thermal damaged plastic libraries, which will make life easy for recycled plastic analysis. So in summary, from this webinar, we see that plastic recycling has become an imminent global issue facing the plastics industry and the environmental community. And we have seen that FTIR is a powerful tool for reliable and cost-effective qualitative analysis of plastics. And with the newly available Shimadzu Plastic Analyzer, measurement and analysis of recycled plastic samples can be performed with ease. So this ends our webinar today, and I will be open for remarks and questions. Thank you.
Thank you very much, Dr. Shaw. Is there any question? ¿Alguna pregunta que tengan ahora? ¿Alguna pregunta? Puede abrir su micrófono o simplemente escribirla en el chat. Con mucho gusto le ayudaremos. Is there any question? You can open your microphone or just write in the chat and we will more than happy to answer them. ¿Alguna pregunta para la doctora Ruth o el doctor Lian Xiao? Somebody's asking what is the cost of the instrument. So the cost is something, the cost is something you need to discuss with your local representative. I don't have that information in front of me. Please feel free to contact your distributor. Okay, what else? There is a question here from Antonio Camacho. Said, can an IR be used in any environment? That's a question for Dr. Xiao. Excuse me, can you repeat that? Can IR be used in any environment? That's what it said, the question. Antonio, if I don't understand the question, you can open your microphone and.
So what's this? Can you repeat that question again?
Can IR be used in any environment?
Environment.
¿Puedes clarificar la pregunta? Parece que no.
I believe the question might be that if the IR can be used in any setting, like in a industrial location, in a lab, or if there is any restriction in terms of where the infrared instrument can be used.
Yes, there is some environmental limitations of where the IR spirit can be used, and it is in the specification of the instrument, and I believe that it has to be within certain room temperatures, so it cannot be used under harsh environmental conditions.
Yeah, usually we do IQQ, right, to make sure it's installed after manufacture specification. So we got another question here from Ms. Lorena Perez Sanchez. She's asking if you can share what are the routine consumable that we recommend for FTIR.
One of the major consumable is the desiccant that is used to keep the environmental for the FTIR dry, and other consumables for the QATR. The consumable may be the crystal, because it can be damaged or abrased over time. But we have a few crystal types to choose from. Some may be harder to be damaged compared to the others. So for example, if you buy the diamond crystal, then it's very durable. That is not to say diamond cannot be damaged, but it will be much more durable compared to, for example, zinc selenite crystal, which is easier damaged. So that is the major consumables of the IR Spirit instrument.
Very much, not too much consumable.
Right.
Thank you, Dr. Lian. Mm-hmm. So other question here is, do you have any data in PVC degradation? That question coming from Mr. Victor Ramos. Do you have any data in PVC degradation you can show?
Okay, I can check the plastics that's included in the
PVC?
in these two libraries. So as I mentioned, there are 14 types for. Sorry, there are 14 types for the UV damage library, and indeed PVC is one of them. And there are 13 types in the thermal damage library. So again, PVC is included. So yes, PVC are included in both the damaged plastics libraries.
Do we have any data or something? That's the question.
Yeah.
Or
the standard spectra are included in the library.
Okay, so, the standard spectra. Okay, okay. I have another question here from Mr. Javier Hernandez. He's saying minimum size of the sample was set as 100 micrometers for regular FTIR analysis. Can the FTIR spectra be obtained even if the sample does not fully cover the FTIR window? Maybe the microscope or something.
I believe so. Yes, I believe so. So 100 micron only occupy a portion of the ATR crystal. The size of the ATR crystal is usually on the order of 1 millimeter. So if it's not fully covered, if there's good contact between the sample and the crystal, you're still able to get spectrum.
Okay. So there's another question here from Mr. Eduardo Ruiz.
Can I add a quick comment regarding that?
Yeah, sure. Go ahead, Doctor.
Yeah, and we actually been doing work with from some size plastics that had a size of 100 micrometers down to 10 micrometers.
It's a very good
I believe
point.
the 100 micrometers minimum is without the microscope, but then with the microscope you can go down to the 10 micrometers.
Yep. Yeah. Very good point. Thank you. So there's another question from Eduardo Ruiz Cardena. He's saying that I need to measure the content of hexamine in resin, phenic resin. Can I use FTIR for this analysis? Hexamine analysis in resins.
So for this mixture analysis, it's a little more complicated. So as I mentioned, there are only about 13 to 14 types of common plastics included in the damaged library, in the damaged plastics library. So maybe some of them will not be available in these damaged plastics libraries. However, each IR spirit also comes with a standard library that has about 2,000 standard spectrums. So the polymer that you're interested in may be found in one of the 2,000 spectrums. So it depends. I think we have to check whether the substance is included or not in the standard library. And also, when it comes to mixture, sometimes it's more difficult to analyze than pure polymer.
Thank you, Dr. Xiao. Antonio, I have another comment from him. He's saying regarding the environment question at the beginning, he's saying, does it need air conditioning, like to work, the FTIR? You know, to keep it inside the manufacturer specification.
Yeah, that's a good idea. Yeah.
Okay.
One quick addition to the question about the examina and
yeah, go ahead.
In the phenolic resins, as Liang mentioned, we can confirm the presence of the chemicals in the standard library, but also with one of the instrumentation that I mentioned earlier, with the pyrolysis GCMS, that could be an alternative also to start characterizing things that are more specific and might have, different concentrations, one main component of the plastic and smaller amounts of other compounds. So that could be an alternative if we confirm that the infrared is not suitable for this specific case. But we'll get back to you on that.
Thank you, Dr. Ruth, for that comment and for the insight. Another question here from Mr. Javier Hernandez. He said, another question is the diamond crystal window for FTIR is appropriate for plastic measurements, the diamond crystal window?
Yes, it is. Yes, the diamond is good for analysis of many types of materials, including plastics.
I have another question here from Mr. Antonio Camacho. He said, do you have in the library information about copolymers?
Probably not. For the damaged plastics library, they are just pure plastics, not copolymers.
Okay, thank you, Dr. Shao.
But there are other like third-party libraries which may contain more species, including copolymers.
And Liang, the user can update the library, correct, with their own spectra?
We have the Shimazu standard library, which includes 10,000, more than 10,000 standard spectrums. So that will cover a lot of different chemical species. Maybe some of them are copolymers. But those are optional. They have to buy either the Shimazu standard library or the libraries from third parties.
And they can still build their own library if they want,
yeah,
right?
That's true. That's true. They can build custom libraries.
Okay, thank you very much, Dr. Shao. Another question here from Rosalba. She said, where can I find some literature that could help me with the functional group that correspond to vibration bands? Where can I find some literature, information about that can help me with the functional group that correspond to vibration bands?
So that's a good question. So these are the IR absorption bands of different countries are available from like different textbooks, for example. But we also have a third-party library, which comes from Wiley. It's the Know-It-All software. So in that software, it will have a lot of information about IR absorption bands and the different functional groups. So that is a great resource for analysis of IR spectrum, in addition to textbooks.
Okay, thank you very much, Shao. So I have another question here from Victor Ramos. He said, is there any change in the spectral feature due to particle size of plastic? I mean, the IR spectrum change if you measure particle of 25 microns against particle of 1 micron size, for example? It's basically saying, is there any, if you have different in sample size, like for example, from 25 microns into 1 millimeter size, is there any change in the IR spectrum with bigger samples or different sample sizes?
Probably not, because the IR spectrum is purely related to the property of the sample, not the size or dimension of the sample. If the degree of degradation are the same for either small or big samples, then their spectrum should look exactly the same.
It will be representative.
Right.
Okay. So
yeah, if one thing that Lian highlighted is that with the infrared, the spectra depends on the properties. Additionally, with the infrared, you can also determine the size of the particle, because especially with the microscope, you can
Yeah,
measure
only with the
size.
microscope. Yes.
And as you said, if the sample is, if the plastic is homogeneous, the spectra will be the same. If it's a piece of plastic with a polymer and a copolymer and an additive, for example, if the piece is big, the sample is bigger or smaller, there can be some changes in the spectrum.
Okay, yeah, very good point. Thank you, Dr. Ruth. So another question from Lorena Perez Sanchez. She said, how many libraries come included by default in the software? How many libraries?
So I don't have the exact number, but I can.
There's one with 12,000 spectra, right? That comes with it.
So that 12,000 is optional. It's not. It does not come by default. The default comes with 2,000 spectra. So it has several libraries. Maybe around 10 libraries, I would say, but I will have to check the exact number. And
you can get back to us with an answer on that one. Thank you.
Yeah.
Mr. Luis Sergio, he's asking which other crystal material can be used in plastics analysis by FTIR. Is the diamond one the best choice for this kind of analysis?
Diamond is very popular, mainly because it's very durable. But for plastics or rubber analysis, you would want to use some material that has a high index of refraction. So germanium is another ideal choice.
Thank you, Dr. Shah. See, I'm scrolling down. I see thanks. I don't know if I'm missing something, but I don't see any other questions. Do you guys have any other question? ¿Alguna otra pregunta para el doctor Shah o la doctora Ruth? Doctora Ruth, ¿alguna pregunta que usted haya visto que yo quizás haya... Yo no veo ninguna otra pregunta en el chat.
I think we covered all of them.
Okay. Okay, so if we don't have any other questions, I just want to say thank you everybody for your assistance. I want to thank Dr. Shah. Yes?
I think a new question just popped up.
Okay, so we have another question from Ms. Lorena Perez Sanchez. She say, how many type of crystal exist for the FTIR analysis? How many crystals? I think we got a nice chart that have all those crystals, right?
Yeah. 3 types of crystals. So we have diamond, zinc, selenite, and germanium.
And germanium.
Yeah.
And of course, you choose them depending on the property of the sample and all the characteristic.
Right.
So that you're absorbing the spectrum or the peaks that you want to measure from the sample and not the crystal.
Yeah,
okay.
That's true.
Thank you, sir. So, ¿alguna otra pregunta adicional antes de cerrar el seminario? Any other questions before we end the webinar? Okay, I see. Thank you. So again, I just want to say thank you everybody for being here. Thank you for your time and for your interest in our Chimaxu product and also in this educational webinar. I want to thank Dr. Shah for his Liang Shah for his time and for this magnificent presentation. I want to also thank Ms. Dr. Ruth Barfield Vega for her contribution and her knowledge in the environmental and all this process of environmental insight that she gave us today. And I want to thank all the audience for your time again, for your presence here in the name of Chimaxu International Department. Thank you very much for giving us this opportunity to serve you. For now, I'm just going to say thank you, everybody. I will stop the presentation now.
Okay.
Thank you. Have a good day.
Thank you. Thank you, everybody.
Thank you, everyone.
Gracias.
Bye-bye. Yeah.
Thank you.